This is a lesson on sequences. Take a look at the sequence 3, 7, 11, 15, 19, and see if you can figure out what comes next. What would come next would be 23, 27, (31), and we could still continue. A sequence is an ordered list, and for us in math, it will be an ordered list of numbers, although it could be an ordered list of pictures or an ordered list of letters. For us, it will be an ordered list of numbers. Perhaps what you saw is what allows us to move from one term to the next. That would be called a recursive definition of this sequence, and maybe you thought it was add 4. And you would be right. If I add 4 and add 4 and add 4 and add 4. But you may have thought something else. Sequences do tend to be a very creative field with lots of possibilities. The notation for sequences that we're going to use is A sub n, where the subscript tells us where we are in the sequence. So for the sequence I have here, A sub 1 will be the first term, or 3. A sub 2 would be the second term, or 7. A sub 3, the third term, which is 11. A sub 4, the fourth term, which is 15. A sub 5, etc. And the definition of a sequence that we're going to be looking for is a functional definition, sometimes called a functional formula, or just a formula. So the functional definition actually says, what could I do to 1 to give me 3? What could I do to 5 to give me 19? And that's a very creative endeavor, and we're going to talk more about that later in the unit. But for now, I will tell you that the functional definition of this sequence is A sub n is equal to 4n minus 1. So if someone said, 1, 2, 3, find the 8th term of this sequence, I would say, oh, A sub 8, 4 times 8 minus 1, 31. And if someone said, what's the 50th term of this sequence, I would say A sub 50, 4 times 50 minus 1, or 199. Okay, that's the benefit of a functional definition or a functional formula. It allows you to go anywhere in the sequence at any time. So our work is to generate the first 5 terms of a sequence if we know its functional definition. So A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. So A sub 1 would be 1/2 times 1 squared. And A sub 2 would be 1/2 times 2 squared. 1/2 times 3 squared. 1/2 times 4 squared. 1/2 times 5 squared. So this would be 1/2, 2, 4 1/2, or 9 halves, 8, 12 1/2, or 25 halves. If this is the functional formula for our sequence and we want the first 5 terms, A sub 1 would be 1 over 1 plus 2. A sub 2 would be 2 over 2 plus 2. A sub 3 would be 3 over 3 plus 2. 4 over 4 plus 2. 5 over 5 plus 2. So 1/3, 2/4, which is 1/2, 3/5, 4/6, which is 2/3, and 5/7. And again, we could keep going. You may not be familiar with this symbol. It's called a factorial in math. So a sub 1 would be 1 factorial. A sub 2 would be 2 factorial. 3 factorial. And what factorial means is a multiplication of all of the natural numbers less than or equal to whatever we're taking the factorial of. So there are no natural numbers less than 1. 1 is the smallest natural number. But for 2, it would be 2 times 1. For 3, it would be 3 times 2 times 1. For 4, it would be 4 times 3 times 2 times 1. For 5, it would be 5 times 4 times 3 times 2 times 1. And a sub 1 would be negative 1 over 1 squared 1. A sub 2 would be negative 1 squared is positive 1 over 2 squared is 4. A sub 3, negative 1 to the third power is negative 1, or 3 squared 9. A sub 4, negative 1 to the fourth power is 1 over 4 squared 16. And a sub 5, negative 1 to the fifth power is negative 1 over 5 squared 25. The last thing I want to look at is I want to go back to some of these and look at what a graphical representation might be. So let me get rid of some things to buy me some space. So this sequence, and I'm just going to make a sketchy kind of graph. The term number, so 1, 2, 3, 4, 5, would go along the x-axis. And then the actual value of that term would go along the y-axis. Okay, so the first term is 3, and the second term is 7, and the third term is 11, and the fourth term is 15. And the thing about sequences that is different from functions is for a function, we would connect these. So if we were looking at f of x is equal to 4x minus 1, or even y is equal to 4x minus 1, we would have connected these and had a line. For a sequence, the points are what we call discrete, and so we don't connect them. There is no a sub 1.5 or a sub 2.3. There are only a first term, a second term, a third term, so just the dots. Let's try this one. Terms. Okay, so the first term is 1/2, and the second term is 2, and the third term is 4.5, and the fourth term is 8, and the fifth term is 12.5. Okay, this is not linear, and in fact, if you look at the functional definition, you might recognize that as a parabola. So we're getting kind of the dots that would describe the right side of a parabola. so you might begin to look at these and compare them to what we think about with functions. So this would, if we graph this as a function, it would be a rational function with horizontal and vertical asymptotes. What it's going to be is dots that would be along that same graph. Okay, so try some of these, and we'll meet again when we meet.